So, good morning, guys. Good morning to NEET WORLD Institute and NEET WORLD YouTube channel, and I hope the voice is clear, right? Okay, fine. So, yesterday we were seeing the topic that is vectors and scalars, right? So, we were up to the topic like the vector addition and subtraction, and we have talked about the multiplication and division also. And in today's class we will talk about the types, that is a triangle law and a parallelogram law of this vector. Okay. Yeah. So like multiplication and division we have talked, and in addition and subtraction we are using this two different cases. So that is, one is parallelogram law and one is triangle law. So how to add a vector? So how to add a vector in the sense, like I'll give a simple trick. So whenever we are adding a vector, I need to take a first vector. For example, I am having two vectors. Let me take vector A and vector B. I need to add this two vector, which means there will be a resultant vector. So resultant vector will be equals to A vector plus B vector. So obviously there will be a vector, that is, there is my A vector, no, right? No. And how to add the second vector? Second vector how to add means, I need to take the second vector. This is my second vector, no. I will take the second vector, I will take this tail and keep in the head of the first vector. So I will keep in the head of the first vector. This is my second vector, B. So this is my A and this is my B. So obviously the resultant will start from the tail of the first vector and ends at the head of the last vector. I am not saying the second vector, I am saying the last vector. For example, if I talk about, there are 3 or 4 vectors, A, B, C, D. So first vector how I need to take? This is my first vector A. Second vector means I need to take the second vector in the head of the first vector. Like second vector tail should be in the head of the first vector. So this is my tail of the second vector B. I will keep this one. Then third vector tail should be head of the second vector, on the head of the second vector. So this is my third vector C. Then fourth vector tail should be in the head of the third vector. So this is my fourth vector D. So on the resultant vector, as I said, it starts from the tail of the first vector and ends in the head of the second vector. Tail of the first vector ends in the head of the second vector, last vector. Okay. Starts at tail of the first vector, ends at head of the last vector. This is my resultant vector. Okay, this is how we will write the vectors, like add the vector add the vectors. Even for subtraction also the same thing. That's it. Okay, we will talk about that one. So parallelogram law. So parallelogram law of a vector addition, used when two vectors act from a common point. Now we have talked about the triangle law. Triangle law gurinchi maatladetappudu, like when I talk about this thing, no, is it looking like a triangle? No, this one, this is my triangle law. But when I talk about the parallelogram law, no, so two vectors are there, vector A and this is my vector B. In this point, no, vector A and B starts in the same point. That's the thing, used when two vectors act from the common point. Okay. So construct a parallelogram with a vector as adjacent sides. As adjacent sides, in the sense, this is my parallelogram, no. This is my parallelogram. When I talk about this, this is my vector B and this is my vector A, and the diagonal from the common point represent the resultant vector, diagonal from the common point. This is my common point, and this is my diagonal. This represent the resultant. Okay, so I need to draw a parallelogram. So where the common point is there, from there every vector has been started, which means a vector, b vector and resultant vector, everything starts from the common point. Okay, but whereas for the triangle I need to arrange in such a way that first vector and second vector will be in the head of the first vector, like similarly third vector will be in the head of the second vector, fourth vector tail will be in the head of the third vector. Okay, and it keeps on going for the n number of vectors also. We will talk about that. Triangle law. Triangle law of a vector addition. Place the tail of the second vector at the head of the first vector. The vector from the tail of the first vector to the head of the second vector gives the resultant vector. I am not saying particularly for the head of the second vector, head of the second vector, head of the last vector. Okay, so application, applicable to vector placed head to tail, that is the thing, head to tail, only head to tail is applicable here, not from the common point. So common point ekkada use avutadante only in the parallelogram, ante head to tail ee condition ekkada use avutadi, triangle law. So triangle law ante head to tail, parallelogram law ante common point. This is the thing I need to keep in mind when I am doing the problem. Okay, now the vector subtraction. So vector like subtraction, no, subtracting a vector is equivalent to adding a negative vector, that's it. Ante subtraction ante enti, ippudu 5 minus 3 ante I can write that 5 plus of minus 3. I am adding, just adding the things, 5 plus and a number which is in the negative form, that's it. So which means change the direction of the vector to be subtracted, that's it. So apply vector addition rule only. Example, same triangle method. Okay, same triangle method. So here resultant vector will be a plus of minus b. You can take a note of this and we will go for the next one. So subtracting a vector, no, that's it. And subtracting a vector ante em ledu, I am adding a vector in the opposite direction ante. Okay, no need to worry about anything. Subtracting a vector oka rule untundi, addition of vector inkoka rule untayi, alanti em ledu. So addition of vector, whatever rule we have seen, the same rule is applicable for the subtraction also. Okay, so just the thing is a minus b anedi, how I will rearrange this resultant vector a minus b, no, how I will rearrange this a plus of minus b. I am adding a negative vector to the positive vector, that's it. Okay, so next is the polygon law of vector addition. Polygon means nothing but the more than 2. Okay, so used to add 3 or more vector acting in a sequence. So as I said here, the example, if I talk about this one, 1 2 3 4 vectors are there, like more than 2 vectors when I take. So how to consider? So same triangle law only we are using there, but like whatever the law, under the triangle law we have seen the condition, no, the same condition only we are using here. Okay, so we will see here, used to add 3 or more vectors acting in a sequence. So which means place a vector head to tail one after the another. The resultant vector is drawn from the tail of the first vector to the head of the last vector. Okay, so condition and application, all vector must be placed in the specific order, head to tail. Okay, this is the first condition. Second condition, resultant vector completes the polygon. So from starts to the end point. So common in force system, displacement and velocity. అంటే ఎక్కడ సారీ అంటే ఎక్కడ లెసన్స్లో ఏ లెసన్స్లో మనం ఇది వాడుతున్నామంటే సో ఫోర్స్ సిస్టమ్ అంటే లాస్ ఆఫ్ మోషన్స్ లైక్ అలాంటి దీంట్లో లైక్ స్ట్రెయిట్ లైన్స్ ప్లేన్స్ మెయిన్ ఎస్పెషలీ ప్లేన్స్ we will use this one. So displacements, velocities etc. Okay, so these are the things. Yeah, in laws of motion we will use the resultant vectors obviously. So special cases, that is equilibrium. If a polygon is close, that is the resultant is 0. Polygon close ante enti sir, adi ela manam close ani cheptam. Simple thing, first vector, second vector, third vector, fourth vector, fifth vector and the sixth vector. For example, A, B, C, D, E, F. So can I able to draw the resultant vector here? Like already 6 vectors are there. Can I able to draw the sixth vector here? That is seventh vector, that is a resultant vector here. Not possible, right? So this kind of vector is called as equilibrium vector. Resultant will be always 0 for this vector. Resultant ani ledhu akkada. So obviously the resultant will be equals to 0. Resultant vector will be equals to 0. So the system is said to be in equilibrium. Net force or displacement becomes 0. Net force, this is net, no, the net, the total net we can say, or the total we can say, or resultant we can say. Okay, so useful in statics and balancing problem. Okay, statics and balancing problem. Balancing problem ekkada manam vadutunnam ante system of particles and rotational motion. Okay, rotational motion we will use there. Yeah, we'll go for the next one. So we'll solve some questions ela solve cheyalani chupistanu ikkada. Okay, the first question, two vectors A is equals to 4 units in east direction. They have given the direction iste em cheppina, it is a vector. When they are not providing direction, for example they have not given the direction here, 4 units, which means it's a units, that's it, 4 units they have given, that's it, it's a scalar quantity, but they have given it's a 4 units east and B is equals to 3 units north. I'll draw the first, the map, north, east, south, west. Okay, so 4 units in the east, 4 units in the east ante idi 4 units. So okay, and B is equals to 3 units. Ela draw cheyalani cheppina. How to draw the second one? Either I can draw like this, but they have given it's in the north, so I'll keep the tail of the second vector on the head of the first vector. I'll draw like this. This is my 3 units, or added using triangle law. Okay, they have given the things here, added using triangle law. Find the magnitude and the direction of the resultant vector. Find the magnitude ante a number adugutunnadu plus the direction they are asking. So resultant vector, how to draw the resultant vector? I need to start from the head of the first vector and tail of the first vector and ends in the head of the second vector. I need to start from the tail of the first vector, ends in the second vector head, which is nothing but this is my resultant vector. Is this looking like a right angle triangle? Yes, fine. Can I use the Pythagoras theorem here? Yes, I can use. So r square is equals to 3 square plus 4 square, which is nothing but 9 plus 16, so which is equals to 25. So r is equals to under root of 25, which gives me 5 units. So r is equals to 5 units. Okay sir, r 5 units వచ్చింది. మరి డైరెక్షన్ ఎలా? ఇది నార్త్, ఇది ఈస్ట్. మరి ఎగ్జాక్ట్గా ఒక 45 డిగ్రీలా వెళ్ళినామంటే I can say this as northeast. So the answer is r is equals to 5 units in north east direction. R is equals to 5 units in northeast direction. That's my answer. Okay, you can take a note of this. Yeah, we'll see a different kind of questions in this. Like a questions అనేది ఎలా అప్రోచ్ అవ్వాలి అని నేను చెప్తాను, ఓకేనా? అండ్ డిఫరెంట్ కైండ్ ఆఫ్ క్వశ్చన్స్ అంటే లైక్ ఎలా క్వశ్చన్ వాళ్ళు అడుగుతున్నారు కూడా నేను చెప్తాను. Cross product questions please. We'll do the cross product also. Yes, see, we'll do that cross product, dot product, everything we will do. I am having that. See, product of two vectors. So in this we'll have dot products as well as cross product also. Okay, we'll do that questions also. No need to worry about that. Okay, మనం ఆ questions ఇలా చేయాలని కూడా నేను చూపిస్తాను, ఓకేనా? సత్యం, యా, వన్స్ ఇది కంప్లీట్ అయిన తర్వాత మనం చూద్దాం అది. ఓకే, ద నెక్స్ట్ క్వశ్చన్. Two vectors of a magnitude 5 units and 12 units act at point with an angle of 90 degree. అంటే ఏం చెప్తున్నాడు? Two vectors of a magnitude 5 units and 12 units act at a point. Okay, fine. They have given like this, like one is acting like this, another one acting like this, which means 5 units and 12 units. Angle between them is 90 degree. Resultant will be like this. It will start from the tail of the first vector, ends in the head of the second vector. Okay? Okay, so fine. So find the resultant vector. Find the resultant vector in the sense similar, no? R square is equals to 90 degree kada, so which means I can use the Pythagoras theorem. So R square is equals to 5 square plus 12 square, which is nothing but 25 plus 12 square is 144. So 144 plus 25, 149, 159, 169. 169. R will be equals to under root of 169, which gives us 13 units. So resultant is 13 units. Okay, this is my resultant for this question. Done? Can we move on for the next one? Yeah, okay. So vector A and vector B. So vector A is given as 6i plus 8j. 6i plus 8j. 13 units. Yes, theta is equals to tan inverse of, fine, that's absolutely correct. Yeah, it's a good observation from you. Theta is equals to tan inverse of 5 by 12. Okay, done. So what is this answer for this question? Ante like vector A and vector B I need to get it, which means the resultant vector they have given as A minus B. A minus B in the sense 6i cap plus 8j cap minus of 4i cap plus 3j cap. What is this answer? So minus I need to take in the inside the bracket. So 6i plus 8j minus 4i minus 3j, which gives us 2i cap plus 5j cap. Is that correct? Is this correct? No? Yes, fine. Resultant vector 2i cap plus 5j cap. Now the question is, what is the magnitude? Only magnitude they are asking. Magnitude ante em cheppanu nenu, I need to take under root of 2 square plus 5 square, that's it. When the question is about only magnitude, yes, it's root 29, fine, it's correct. Only magnitude ante r will be equals to idi r bar kada, but magnitude anetapudu like only I need to take only r, so I no need to represent the arrow here. Okay, so under root of 2 square plus 5 square, which gives us 4 plus 25, that is root 29 units. Okay, root 29 units, that's it, no? Fine. Okay, now two equal vectors of 10 units each acts in the opposite direction. Ante resultant vector, what is the resultant vector? Acts in the opposite direction. A is equals to 10 I cap, 10 I cap ga తీసుకుంటే అంటే opposite direction of I is minus I, no? So B will be equals to minus 10 I cap. అంటే క్వశ్చన్ కేర్ఫుల్గా అండర్స్టాండ్ చేసుకోండి. Two vectors, equal vectors of 10 units each act in opposite direction. What is the resultant vector? Resultant vector will be r is equals to a plus b, which is nothing but 10 I cap minus 10 I cap is equals to 0. Resultant will be 0. Okay, both are in anti-parallel direction, no? Okay, and what about the angle between them? Angle between them, this is my I cap and this is my minus I cap, so the angle between them will be 180 degree. 180 degree. So please tell me once again. Okay, see ikkada ఏమంటే two equal vector అని చెప్పాడు. Two equal vector which is of 10 units each act in opposite direction. Either I can take I and minus I, j or minus j, k or minus k. What is it? I is nothing but x axis, j is nothing but y axis and k is nothing but z axis. And I ante positive x axis, minus I ante negative x axis. So I have taken this as my reference point. Okay, act in the opposite direction, which means if I take a is equals to 10 I cap ante b will be in the opposite direction, no? Minus 10 I cap. Suppose if I consider a is equals to minus 10 j cap, minus 10 j cap, which means b will be equals to 10 j cap. Got it? So I need to consider in the opposite direction. I guess you got it, no? So 0 I cap or 0, just 0, that's it, just 0, because no, I am in the origin అనేటప్పుడు 0, 0, 0. I am not going in I, j or k. I am just standing in the center point. Okay, done. So you got the answer, no? Like it's not a 0 I cap, it's just 0, that's it. Okay, okay, we'll see the next one. అంటే వెక్టర్స్ ఎక్కడ యూజ్ చేస్తామని చూద్దాం. Why vectors are essential for kinematics? Kinematics is nothing but the chapter which we are going to concentrate of the class 11th, motion in a straight line, motion in a plane. These are the two things kinematics అని చెప్తాం. Directions of zero vector. Direction of zero vector, like there is no direction for zero vector, just 0, that's it, just 0 it is. Can you say 0 is a positive or negative? No, right? అది పాజిటివ్ అని చెప్పలేము, నెగటివ్ అని కూడా చెప్పలేము. ఓకే, see there is a thing, I can't say 0 as a negative or a positive, but 0 is a even. Okay, that's the condition. So helps in distinguish between the distance versus displacement. Distance means only magnitude, displacement means both magnitude and direction. So critical for solving two-dimensional motion problems and used in applying equations of motion in a vector. Yes, we will talk about that one. Okay, yeah, I'll take an example here. A ball is thrown at 20 meter per second at an angle of 30 degree to the horizontal. Sir, before that, no, I'll tell you one thing, component of a vector. How to take the component? It's important thing. It is very, very, very important thing. Component of a vector. So in this, two things we will talk. With respect to horizontal, ante I am respecting the horizontal line. I am respecting the horizontal line, which means I am just ignoring the vertical. Okay, the next one is with respect to vertical. అంటే ఏంటి సార్ ఇది with respect to horizontal, with respect to vertical అంటే? Yes, the thing is, if I consider there is a graph, x axis and y axis. What did I told? Like if I stand, that is my vertical. If a thing is lying down, that is my horizontal. Now if I take a vector like this, vector, for example, let me take this as a vector. So a vector ila undi, and this a vector making an angle with respect to x axis, making an angle with respect to x axis, which means there is a horizontal line. So initially the line, like the vector was like this. Now this vector is making an angle with respect to horizontal. With respect to horizontal I am talking. Okay, with respect to horizontal, which means with respect to, అంటే ఇక్కడ ఏమైనా యాంగిల్ ఉందో, like a side angle ఉందో, that one I will call that as cos. Okay, cos theta. This is my cos theta. Wherever the angle is not there, that one I will call that as sin theta. Cos theta and sin theta. Similarly, ఇప్పుడు if I talk like this is my vector A, and vector A is making an angle with respect to y axis, ante vertical, then this is my cos theta and this is my sin theta. Hope you got it, no? H is equals to 5 meter, r is equals to 20 root 3, t is equals to 2 seconds for this projectile motion. You went for projectile motion only. Sir, north, south, west from north, south, west from east, doubt. ఏంటి సార్ అది నార్త్ సౌత్ వెస్ట్ ఫ్రమ్ ఈస్ట్ డౌట్ అంటే నాకు అర్థం అవ్వట్లేదు ఏం అడుగుతున్నారని. అంటే నార్త్ డైరెక్షన్ ఏంటి, సౌత్ డైరెక్షన్ ఏంటి, ఈస్ట్ ఏంటి, వెస్ట్ ఏంటి అని అడుగుతున్నారా ఏంటి? Okay, sir, please in English. Okay, sir, no issues. And a guy was asking, sir, north, south, west, from east, out. You want the direction, right? Just the direction. Okay, fine. So just draw the axis like this. Okay. So right side of u will be east, and left side obviously it will be west. West and east will be opposite in direction. Top will be north, bottom will be south. Got it? No, got the direction. Okay. So I hope you got the components right here. So whenever I am taking the angle with respect to x axis will be my cos theta, y axis will be my sin theta, and whenever I am taking theta with respect to y axis will be my cos theta and x axis will be my sin theta. Okay. Now we will go for this one. A ball is thrown 20 meter per second at an angle 30 degree to the horizontal. Resolve the initial vector. Okay. So initial velocity into horizontal ux cos theta, vertical uy sin theta. Only just a vector, that's it. No need to solve what is the height of that and this type I asking. Oh, this question you are asking. Okay. This question I am not asking what is the range, what is the height and what is the time. Still we are not going in, like we have not gone in through that one, no. Yeah, if you want I will give the formula for that, like h is equals to u square sin square theta by 2g, r is equals to u square sin 2 theta by g, and t is equals to 2u sin theta by g. Okay, you can use this formula and you can get it. Okay, I will talk about this one. A ball is thrown at 20 meter per second. Okay sir, thrown 20 meter per second, and the next sentence what they are saying, angle of 30 degree to the horizontal. Ante I have thrown like this with respect to horizontal, how much angle is 30 degree. So 20 meter per second, this is my 20 meter per second. Okay, so I need to take the component, which means this is cos and this is sin, or this is cos or this one is sin. So whenever the angle is with respect to that axis will be called as cos theta, or the other axis will be sin theta. So with respect to x I will call this as cos 30 degree, and what is this one? 20 cos 30 degree. And what about this one? 20 sin 30 degree. Got this? Okay, so this is my uy and this is my ux. So uy they were asking and ux also they were asking. I have given the things. Use kinematic equation separately in x and y direction. Yes, I have used separately. Done. So the next one is, ఈ కాంపోనెంట్ అని ఇప్పుడే మాట్లాడాం మనం. Like now only I have talked about this component. Vector can be represented in terms of magnitude and direction. The other term is I can represent the vector in terms of x axis and y axis, which is nothing but change in x and change in y. That one we have discussed here. Okay, so if you are having any kind of doubts you can ask me based on this one, component of a vector. So I hope no doubts, right? Component of a vector. Now we'll do a question, a small question. Okay, a force F has a magnitude of 15 Newton, direction F is 37 degree from the negative x axis. So I have given the things. So what is 37 degree of sine cos, what is 53 degree of of sine and cos also. So I have told you that most of the questions can be asked in 37 and 53. So I told you to remember this 3 4 5 triangle, 3 4 5 triangle. Okay, whoever have attend the first class of this bridge course, no, they would have got what is this and how to take the angle also. Okay, so I'll tell you, no need to worry about that. I'll tell you how to take that once again. Okay, so first thing, force F has a magnitude of 15 Newton. Okay, direction of F is 37 degree from the negative x axis. So negative x axis means I need to draw 37 degree minus x axis, this one. This is my negative x axis 37 degree and this is my F. So towards positive y axis, ante x axis to y axis, this is my 37 degree. Okay, I can take this also minus y axis also, but they have properly mentioned negative x axis towards positive y axis. Represent F in terms of I and j. Represent F in terms of I as well as j. So F can be written as F cos 37 degree, which which one, minus I or plus I? This is minus I. Okay, I'll write here minus I cap. Okay, and this one is F sin 37 degree plus j cap, positive, no, positive y axis, no, plus j cap. So F is equals to, so what is F? 15 Newton and sin 37, sorry, it's not sin, it is cos, no. So cos 37 degree and this is minus I cap plus 15 sin 37 degree j cap. Okay, now the thing is 3, 4, 5 triangle. Okay, I will take here. So 53 and 37, this is my 90 degree. Okay, so which is more? 5 is more, so keep in the hypotenuse. This is 3 and this is 4, that's it. So sin 30, I mean cos 37, so cos 37 in the sense adjacent by hypotenuse. So minus 15 into 4 by 5 I cap plus 15, so this is 3 by 5 j cap. So 1 times and this is 3 times, so minus 12 I cap and this is 1 times and this is 3 times, so plus 9 j cap. Sir, ఇప్పుడు ఇలా తీసుకున్నాము and I will get the same answer. What I told, if I take the magnitude, this is vector form. If I take the magnitude, I should get the same thing, which means F is equals to under root of 12 square, like minus 12 square plus 9 square, which gives us root 144 plus 81. Root 144 plus 81, how much? So 140 plus 80, it is 220, 225. So 15 square is 225. I am getting the answer. That is 15 Newton. That's it. Okay. And what they have asked in terms of x and y, this is the answer. This is my answer. This is my answer. Okay. So I hope you understood some concept of this vector addition, subtraction, multiplication and division in this class, no? So in the next class we are going to talk about what is the dot product and what is the cross product of this vector, and that is a very crucial thing. Okay, so most of the question can be asked like in the torque is equals to F cross R, or else work done is equals to F dot S. So many questions will be based on that. So please try to attend the next class without fail. Okay, so we'll meet in the next class, guys. Bye bye.